Oxidation reduction reactions are also known as redox reactions. These are reactions where electrons are going to be transferred between your reactants. So one element is going to gain electrons while the other one loses electrons. So something to remember is that Leo the lion says grr. Okay, so here's Leo. So when you lose electrons, you're oxidized. Gaining electrons means you've undergone reduction. So remember, Leo says grr. Oxidation is the loss of electrons. For example, if you take a sodium atom, it loses an electron, it forms a sodium ion. Reduction is where you gain electrons. So for example, oxygen is going to gain electrons to become oxide. Oxidation number is the same thing as the charge. Okay, so when you hear that term oxidation number, think charge. And we're going to follow some rules for determining the charge of an atom in a compound. So here are the rules. So pause the video, jot them down for a second. So atoms that are in elemental form are going to have an oxidation number of 0. So if they're just a plain old element all by themselves, they're going to have a charge of 0. For example, hydrogen gas, H2, is 0. Carbon, 0. Aluminum, 0. Monatomic ions have an oxidation number equal to their charge on the periodic table. Most of the time, this is what's going to happen. You're going to know the charges of all but the one you're trying to find from the periodic table. So for example, potassium we know is +1. Oxygen is almost always -2. Nonmetals are usually going to have negative numbers. Like we said, oxygen is usually -2, except when it's a peroxide, but that's a pretty rare situation. Hydrogen is normally +1 if it's bonded to a nonmetal, and -1 when it's bonded to a metal. Fluorine is almost always -1. Halogens in general are -1 unless they're combined with oxygen, and this is where they're positive. Now when you add up the sum of all the charges, you should get 0. Remember, we have neutral compounds. Alright, so the big thing to remember here is that the charges you're going to know the charges from the periodic table of all but the element in question. So let's look at some examples. So let's find the charge of phosphorus in diphosphorus pentoxide. Alright, so the first thing that we're going to do, we're going to use the same method we've always used, where we list our elements and we list how many. Now, here's what we're going to do. We don't know what this charge of phosphorus is, but we do know what the charge of oxygen is. So it's -2. So first table, the first column is how many, second one is the charge. Okay? So 5 times -2 is going to be -10. Now this down here is your overall charge, and that's typically going to be 0, okay, especially when you have a compound like this. So 0 plus -10, I'm sorry, what plus -10 gives me 0? That's going to be +10, okay? Now we have 2 phosphorus. We have a total of 10 positive charges. So that means that every phosphorus has a +5 charge. So the charge on the phosphorus here is +5. Now let's look at this one, sodium hydride. Alright, so if we're looking for hydrogen here, that means we know what sodium is. So we have 1 sodium, 1 hydrogen. So if we look at the periodic table, sodium is +1. We don't know this hydrogen yet. So 1 times +1 gives me +1. Overall charge of 0. So +1 plus what equals 0? Okay, so that has to be a -1. There's one of them, so that hydrogen has a -1 charge. Now let's find the charge of sulfur in sodium sulfate. So let's follow the same steps. Sodium, sulfur, oxygen. We have 2, 1, and 4. Alright, now, because sulfur is the one we're looking for, we know the charge of the others. So sodium, if we look at the periodic table, is a +1. Okay, so 2 times +1 is a +2. Oxygen, we know, is -2. So 4 of those, that's -8. Again, overall charge is 0. So we have a +2 and a -8, and we have to add those up with something to get 0. So what we're going to have here is a plus 6. Okay, so plus 2 plus 6 is positive 8. Plus a negative 8 gives me 0. So that means we have 1 sulfur, so it has to be a plus 6. Now let's look at the sulfur here in potassium sulfite. Alright, so we have K, S, and O. We have 2, 1, and 3. Alright, so potassium is a plus 1. We don't know sulfur. Oxygen is minus 2. Overall charge is 0. So our sulfur in this case must be a plus 4. Now redox reactions are going to be everywhere. When you're given a reaction, the first thing that you need to do is find the charges of each reactant and product. If the oxidation number goes up, then it's being oxidized. In other words, if it's losing electrons. If the element's oxidation number goes down, it's being reduced. So if it gains electrons, it's being reduced. Now, oxidation does not happen without reduction. Reduction does not happen without oxidation. So they both have to happen. So let's look at an example. This is a single replacement reaction, and we have a metal replacing another metal. So what we need to do first is figure out the charges for all of our species. Now, because we have sulfate on both sides, we can just, sorry, I don't know what I did. Okay, I think I fixed it. So because sulfate is on both sides, we can just go ahead and use the charge for the whole ion. All right, now, let's look at this magnesium here. It's by itself, so that means that its charge is 0. Same thing goes for this cobalt over here. It's by itself, so it's 0. So now we have to look at the charges in our compounds. So cobalt is a transition metal. So what we have to do is unflip. So if we have a 1-to-1 ratio here, and sulfate is minus 2, then that means that that cobalt had to have been a plus 2. Now if we look at magnesium over here, same thing applies. Magnesium has to be plus 2, and this is what it is on the periodic table as well. So what we have to do now is write two half reactions. So our magnesium is going from magnesium 0 to magnesium plus 2, and our cobalt is going from plus 2 to 0. So now we want to balance these charges by adding electrons. Okay, you can't subtract electrons. Okay, if electrons are lost, that means they appear as a product. If they are gained, they appear as a reactant. So in this case, for our magnesium, we have magnesium 0 here, magnesium plus 2 here. So that means that the 2 electrons must be on the product side. So this is a loss of electrons. This is oxidation. So for cobalt, we have cobalt 0 here. So our 2 electrons must go in as a reactant. So we have gained electrons. So this is reduction. So magnesium is oxidized, while cobalt plus 2 is reduced. For our second example, we're going to first of all figure out our charges. So aluminum here is 0, it's by itself. This hydrogen over here is also by itself, so that's 0. Now if we look in our compounds here, we have hydrogen first. When hydrogen is first, remember it's always a plus 1. And bromine, if we look at the periodic table, is a negative 1. Over here, aluminum, looking at the periodic table, is plus 3. Bromine is minus 1. So in this case, we have aluminum going from 0 to plus 3. And we have hydrogen going from plus 1 to 0. So for aluminum, our electrons are going to need to be lost so they appear on the product side. So aluminum is oxidized. Hydrogen has to gain an electron, so it appears as a reactant. So hydrogen has gained the electron, so it is reduced. So aluminum is oxidized, and hydrogen plus 1 is reduced. All right, one more example here. Now we have nickel plus chlorine yielding nickel 2 chloride. Okay, so this is a synthesis reaction where we see this happening. So the nickel by itself is 0. Chlorine by itself is also 0. So now we have to look at our charges here. Well, nickel's a transition metal, so we have to look at chlorine on the periodic table, and it's a -1. All right, so we have a 1:2 ratio. So if we unflip those, all right, notice the 2 here, that means that nickel is plus 2. So if we look at what's going on, our half reactions, nickel 0 goes to nickel plus 2, and chlorine 0 goes to chloride, chlorine minus 1. Now don't worry about balancing. You're not going to have to balance any of these, so that's why I haven't done any of that. All right, so nickel, to go from 0 to plus 2, is going to lose electrons, so it is oxidized. Chlorine is going to have to gain electrons, so it is reduced. And it just happened to work out that the first one I did was oxidation and the second was reduction. For all of these examples, it just depends on the way that you write it. All right, so if we're gonna answer this question, nickel is oxidized and chlorine is reduced.